Welcome. This podcast is going to be an introduction to sequences. A sequence is just a collection of numbers written in an order, and you will notice by looking at these sequences, if you start with 2 and add 2 each time, that's how you get to each new number. For the next one, we're going to start with 1. You can see that we're adding 3 each time. And the next one, we're actually going to go down 5 each time. All of these sequences are called an arithmetic sequence, and arithmetic sequences all have a common difference. How do you find that common difference? You always find that one by subtracting. You take a term, and you always subtract the previous term. 6 minus 4 is 2. 12 minus 10 is 2. It doesn't matter where you do it. Same thing down here. If I take 5 minus 10, it's negative 5. If I take 10 minus 15, that's negative 5. So for this particular sequence, the common difference is 2. The common difference is 3. And here the common difference is negative 5. Let's give you some examples of some different kinds of sequences. You'll notice that in these sequences, they don't go up or down by the same amount. What's actually happening is that to start with this particular sequence, we're multiplying each term by 2. In this one, we're multiplying each term by 3. We'll come back to this one in just a minute. When you are multiplying each term by a number, these sequences are called geometric sequences, and they all have a common ratio. Note that when you are actually finding that ratio, if you do get a fraction, you want to keep it as a fraction, not as a decimal. Can you find that common ratio? Always by dividing. Term by the previous term. Call that common ratio R. In the first one, the common ratio is 2. The second one, the common ratio is going to be 3. This one, let's take a term divided by the previous term. You can do that for any of them. Let's take 9 divided by 6. They all have to be equal to the same thing. We're going to reduce that fraction to just 3 halves. So we say that common ratio is 3 halves. It is also 1.5, but let's keep it as a fraction. Can you identify each of these sequences as either arithmetic or geometric, and then find either the common difference or the common ratio? And one other thing I want you to do is, could you actually add the next term? Why don't you pause, go ahead and do that, and then come back. Let's look at the answers. The answer to the first one, it's going to be a geometric sequence. It's being divided by 2. Divided by 2 is being multiplied by 1/2. So that common ratio is 1/2. If you take 1.75 and divide it by 2, you're going to get 0.875. Next one's arithmetic. It's going up by 4 each time. The next term would be 36. The next one is geometric. Note that if you divide a term by the previous term, like negative 9 over 3, that ratio is going to be minus 3. Negative 243 divided by, times negative 3 is going to be 729. The last one is geometric. Let's take a term, let's take 1/2, and let's divide that by 3/4. Well, how do you do that? Well, that's going to be 1/2 divided by 3/4. Remember how you divide fractions? 1/2 times the reciprocal, which is 4/3, which is 4 over 6, which when you reduce it, gives you a ratio of 2/3. 4 over 27, times 2/3, just times the ratio of 2/3 is going to give me 8 over 81. How do you write sequences? Well, there's two ways to write sequences. You can write a sequence recursively, meaning that each new term depends upon the previous term, or you can write a sequence explicitly. This means you can find any term in the sequence directly. For this podcast, what we're going to do is we're going to be focusing just on writing sequences recursively, and in the next podcast, we'll write sequences explicitly. So writing sequences recursively. Remember that recursively means that each new term depends upon the previous term. Here I've given you a sequence. It's going to be an arithmetic sequence. It's going up by 5 each time. So to write an arithmetic sequence recursively, the first thing we're going to do is we're going to use the letter U to label these sequences. This n down here is a subscript. So when n is 1, we have U sub 1. In this case, it's 6. I have U sub 2. In this case, it's 11, etc., etc. So what do we need to do? Well, we need to identify the initial term. We're going to label that U sub 1. We need to find that common difference. We're going to label that as D. And we need to know the starting value of n. Usually you just give that. How does this work? Well, the general form of a sequence, of a recursive sequence, and it's arithmetic, is going to look like this. U sub 1 is the initial value. U sub n, the nth value, is equal to U sub n minus 1, the previous value plus that common difference. N is always greater than or equal to 1 in this case. What does that mean? That means that when n starts at 1, U sub n is U sub 1. We're given U sub 1. We then go up by whole numbers. So U sub 2. Well, U sub 2 is equal to U sub 2 minus 1, which is U sub 1 plus that common difference. So for this sequence up here, U sub 1 is equal to 6. U sub n is equal to U sub n minus 1, and sometimes I'll put that in parentheses. Common difference is 5. And we want n to start at 1 and then go up by 1. So that is a way to write that sequence. Let's do some more. Can you write a recursive formula for the following sequences? The first one I actually did for you. You see in this case, this is going up by 7 each time. So that common difference is 7. The initial value is 2, so U sub 1 is 2. U sub n is equal to U sub n minus 1 plus that common difference, which is 7, and n starts at 1. Can you actually pause this and do the remaining sequences? Assume that you've done them. Let's take a look. For the next sequence, U sub 1 is equal to 4. We see that it is going up by 12 each time, so that common difference is equal to 12. So U sub n is equal to U sub n minus 1 plus 12. And again, n is just going to start at 1 and go up. Next one, U sub 1 is equal to negative 3. Negative 3 to negative 1, negative 1 to 1, 1 to 3. We can see that that common difference is 2. It's going up by 2 each time. So U sub n is equal to U sub n minus 1 plus 2. And again, we just write this in. Last one turns out to be the same as the first one. And so it's actually just going to be this one right here. Let's keep going. writing sequences recursively. What about geometric sequences? Notice that this sequence first goes up by 8, but then it goes up by 24, so it's not arithmetic. It's actually getting multiplied by 3 each time, so that common ratio is 3. We need to label the initial term. We need to find that common ratio, R, and we need to write the starting value. So the general form for recursive sequence when it's geometric is u sub 1 is equal to the initial value. U sub n is equal to u sub n minus 1 times that common ratio. So for this sequence up here, u sub 1 is equal to 4. U sub n is equal to u sub n minus 1 times 3. And n is greater than or equal to 1. Let's practice this a little bit. Can you write the recursive formula for the following sequences? And again, the first one's done for you. We look at the first one, we see that it's getting multiplied by 4 each time, so that common ratio is 4. I didn't put in u sub 1, so I need to put in that u sub 1 is equal to 2. U sub n is equal to u sub n minus 1 times 4, and there's n. Can you pause this and do the remaining ones? On the next sequence, we see that u sub 1 is equal to 8. And this is multiplied by -2. So this should be positive, this should be negative, this should be positive, this should be negative. To make that actually work. So u sub n is equal to u sub n minus 1 times -2, n is greater than or equal to 1. So, my mistake on that one. Let's skip that one too, and let's just go right to this one. So, u sub 1 is equal to 4/9. U sub n is equal to u sub n minus 1. What is that common ratio? Let's do 1/3 divided by 4/9, which is 1/3 times 9 over 4, 9 over 12, divide them both by 3, and we get a common ratio of 3/4. So that common ratio is 3/4. Let's check it. 4/9 times 3/4 is going to give me, after some canceling, it's going to be 1/3. 1/3 times 3/4, so that works. And n is greater than or equal to 1. Very good.